Assalamualaikum warahmatullahi wabarakatuh and very good day to everyone. First of all, I would like to thanks to IEEE Symposium on Industrial Electronic and Application ISIA 2021 for accepting this article to be presented in this symposium. So the paper title is Low Power Smoke Detector and Monitoring System Using Star Topology for IoT Application. And the authors are Muhammad Faiz Akmal Mohani, Abdul Karim Halim, Muhammad Faizul Mat Idros, Syed Abdul Muttalib Al-Junid, Abdul Hadi Abdul Razak, Fairul Nazmi Osman, and Nur Hazdin Khairuddin. And the project has been conducted at School of Electrical Engineering, College of Engineering, University Technology Marak, Malaysia. This is a talking point in this presentation. The first part is the abstract for the project and followed by the research gap, which drive and motivate us to this project. Then third part is the review on the recent development, which we presented under the smoke detector review. And the procedure in conducting this research is highlighted in the methodology part. All development, testing, and validation results are listed in the result part of the presentation. Finally, all finding and future suggestions are concluded in the conclusion part. So this is the overall project abstract. So the project is to design a low-power smoke detector and monitoring system using the star topology protocol based on IoT application. And the gap we are trying to solve is the conventional smoke detector systems are expensive and cover short distance. Then the target requirement will be cost-effective system, compact design, expandable, simple installation, and have wider coverage. There are 4 project objectives in this project, which are the first one is to design the hardware for smoke detector and monitoring system that are cost-effective, low power, and wirelessly connected. The second objective is to compose the software that support the hardware to perform the operation for Wi-Fi, GSM, alarm, and cloud database. The third objective is to integrate the low power technique using interrupt and sleep mode in order to minimize the power consumption and prolong the battery life. Then the fourth objective is to integrate the hardware and software of the smoke detector and monitoring system to interact with each other wirelessly under the low power mode and store result in the ThinkSpeak cloud database. So under the methodology, so the development will be in this project is using ESP826601 Node MC Wi-Fi, and the database is being developed by using ThinkSpeak, connected by using ThinkSpeak. Then the result, the system has successfully developed and worked in the low mode, power mode, and communicate with the central unit effectively. Then as a conclusion, the result construct able to sense the same sensitivity as the other smoke detector and solving the limitation issue by the conventional system. This is the motivation which drives us of doing this project. So the first motivation is the conventional smoke detectors are very expensive and lower coverage area. Then the conventional smoke detector systems are using a lot of power consumption, which always on mode. Then certain smoke detector in the market do not have wireless protocol, which built in the system and do not have any data logging capabilities, can track the existing data or the previous data recorded. So this is some of the work that has been done before. So by O Khalifa, the RF technology into the smoke detector circuitry, which the smoke detector send a low voltage signal to the control unit and all other smoke detector in the system. Then by H. Hugh Gang, he said that a wireless multi-sensor fire detection and alarm system can be performed based on the ARM, which the system use NRF 2401 for short-range wireless communication and GPRS for long-distance wireless communication, ARM9 for central console wireless multi-sensor fire detector for node, and BP algorithm is used for judging the probability of fire. Then the third works by S. Madhura highlight that mobile technologies, including the global system for the mobile communication GSM and ZigBee short-range wireless data connection technology, could be used to monitor and use in the fire detection system. So on the other hand, the works by A. Ashita et al. Said that the development convenience and reliable GSM-based fire alarm system for alerting fire and smoke to the owner outside the building and industry premise, while Averill said that the test that the smoke alarm or either the ionization types for photoelectric type consistently provide time for occupant to escape from the most residential fire, while the Chen said that among the modern smoke detector, photoelectric types are the more commonly used. This device acts upon the light scattering principle, which means that the light beam and the photoelectric receive a perpendicular when the no smoke is present. So this is the methodology for this work. So we group the methodology in the three main part, which the first one is system design and operation, and followed by hardware and software development, and the last will be the testing and verification. So there are three main important parts in the system design and operation. The first part is the overall system functionality. The second is hardware system operation, and then the third is the software operation. So this is a very important in guide us in developing the project function for the software, for the system, hardware, as well for the software. For the hardware and software development, the architecture is very important. That's why we come up with the three different figures in this slide to show that how we develop the architecture. So the first part in figure 4, it shows that the block diagram for the complete low power smoke detector and monitoring system using the star topology for IoT application. It is how the overall system is connected. And then the second figure, figure 5, it shows that the block diagram for the low power smoke detector and monitoring system using the star topology for IoT application control unit. This one, we zoom in more detail to the control unit. And then the third figure, figure 6, is a block diagram for the low power smoke detector and monitoring system using the star topology for IoT application smoke sensor node. That will be for the sensor node. Okay, testing and verification is very important as to ensure that the system works properly. There is some figures of the work which we have captured. So you can see that the figure 7 is a complete circuit for the control unit. Then figure 8 is the complete circuit for the alarm node. And then the figure number 9 is the complete circuit for the sensor node. So we have three different circuits in this project. And then the figure 10 is a low power smoke detector and monitoring system using the star topology for IoT application. It is for the overall unit. So you can see that there are three different units over there with the three different circuits. So we need to test as to ensure that the system works properly and according to the target that we are setting. Okay, this is the final result from the project that we have developed and construct. So you can see that in figure 9, the complete system for the low power smoke detector and monitoring system using star topology for IoT application. It's been developed by using a PCB and connected to the node MCU. Then figure 10 is the control unit for the low power smoke detector and monitoring system using the star topology for IoT application. That will be the control unit. And then figure number 11 is a node for the project. And then figure number 12 is the alarm node for the low power smoke detector and monitoring system by using the topology of IoT application. This is the overall pictures of the final output from the project that we have developed. This two table shows that the data over the test that we have conducted on the project. So we have the test on the sensor node, and then we have the test on the low power detector and conventional smoke detector power consumption during no measurement and no transmission. So the two of the data shows that the system work accordingly to what we expect from end of the project. So we also test the system in the real environment. So you can see that there will be some voltage triggers in the photoelectric sensor circuit when the system sense the smoke and fire, while you can see that from figure 14, it shows the power consumption required for the data logging to record the data. And then figure 15 shows how sensitive the systems in sensing the temperature. Then while figure 16 shows how the system identify and the latitude and longitude location of the sensor. So figure 17, this is a print screens of the notification sending by system to the user, and then figure 18 is the print screen for the graphical user interface for the Google Assistant application. It is some of the result for the during the implementation. So finally, in conclusion, the low power smoke detector and monitoring system using star topology for IoT application is successfully developed and tested. So all the criteria which we have stated or we are targeted, such as cost efficient, compact design, easy expandable, simple to install, and have broad coverage, are achievable. And then moreover, the data will be transmitted in real time into the website by using the UDP and data transfer, and succeed to provide detection point and temperature data precisely. Then the next steps, what we suggest is we need to make sure the proper test as to ensure that the system robust in the real environment. Finally, we would like to acknowledge the School of Electrical Engineering, College of Engineering, UITM, for the support given to this project. It is some of the works that we are referred and cited in this project. So with that, thank you so much.